All right, let's start talking about Apple logo. So I have my trusty emulator here, and let's go ahead and change it to color, I think, because that'll be prettier. So Logo is a language that was invented by Seymour Papert, and it was really meant as an educational language. There are a number of implementations of it on various platforms. The Apple logo, I think, was based around UCSD logo, or University of California logo. I'll have to check that later. So interestingly, one thing that jumps out at you is if you look at the font here, you can see at the bottom of the screen, press return to start logo. That's not standard Apple II text. So I think they are actually generating all that text on the graphics display. And those look a little strange. So what can we do in Logo? Let's see. I don't remember much Logo, but probably we can type a number. You didn't say what to do with 65. All right, let's say, can we output it? Can we do that in a procedure? Can I quote it? No. Can I print it? Okay, I can print it. Can we do functions? Let's see. Maybe we can do arithmetic. Okay, we can do some arithmetic, so that's good. The main type of program you see in Logo, even though people call it a functional programming language, most of the work people do with it is largely procedural. And in particular, they do what are called turtle graphics. So let's see, can we do, I don't remember the move turtle. Is it forward? I think it's forward. Let's just go forward 90. Okay, and we switched into the graphics mode, and you could see there's our turtle is the little triangle. We told it to move forward 90. We can, let's make a right angle. We can move forward another 20. No, maybe I should spell it right. Forward 20, yeah, that all works. How do I, let's see, I think I can lift up the pen. Forward another 90. I can't type today. Since I lifted the pen up, we're not drawing a line. Let's say pen down. I'm not quite sure how we do colors. Pen color, maybe. Pen color, let's see, 4, no? All right. Clear screen, wow, I lucked out there. So let's see if we can create a function. So I believe the way you create a function in Apple Logo, at least, is to say to, and then the verb you want, and then the stuff in the function, and then the word end. So we're going to say, let's say to pattern. Let's say we're going to go forward 90, right, let's say 120, forward, let's go 90 again, right, another 60, forward 40, right, 20, and end. Okay, so now we have this function called pattern. I don't know that it'll be very interesting, but let's run it and see what happens. All right, we did some things there. Well, that starts to look a little bit interesting if we do it a bunch of times. But I'd really like to have it repeat itself. So can we edit it? Edit pattern. I think I have to quote it because I want to edit the function there, and it drops us into our full screen editor. So what I want to do is I want to have this thing repeat itself a bunch of times. So I think the command for that is just, or the structure for that is just repeat and then some number. So let's say, I don't know, 20. And then I believe repeat block needs an end. We could indent these things here just a little. See if that works. Apple escape, Apple A to accept. All right, I sure hope you don't know how to end. So obviously, repeat is not. Let's see. I'm going to look this up right now. There we go. Logo for beginners. Thrill as I Google. Oh, it's actually brackets. My bad. Again, with the forgetting to quote. Repeat 20. Gotta do that. And then that. Will that work? Oh, look at that. We're going to try it. Fingers crossed. And it did not work. Why not? Maybe these all need to be on the same line. Seems kind of crazy to me, but let's try it anyway. And then close the brace. Okay. All right, there we go. And so now we've got a slightly more interesting pattern that we can draw. So this is something that I wanted to explore a little bit, which is the idea that people call it a functional programming language, but in practice, if you try and use it functionally, I mean, everything the language is kind of optimized for is a side effect. So let's do a specific example of this. I'm just going to edit that to get us into text mode there. All right, so let's say what's the simplest possible function or procedure we could have? Well, how about we add 1 to an integer? So let's make a new function. So to add 1, and I believe we have to give it a parameter, and I think a colon followed by some name is the way we do that. So how do we do add 1? To add 1, num. We want to output this. Output in this context does not mean output to the screen. It means output from the function. It's return, essentially. Output num plus 1. Oh, look at that. Does it actually work? You don't see what to do with 8. Good, yes, so this actually worked. We could say print 100, print add 1, 100, and it printed 101. What happens if we give this something that isn't a number? Doesn't like hello as input and add 1. So I assume that's a runtime check, essentially. The language isn't, I don't think it's strictly typed, but obviously there's some type checking going on here. Okay, so now we have this function add 1. So can we create another function that uses add 1? This seemed to me to be, people talk about one thing that many functional languages have is this idea of functions as first-class objects. So let's find out if Logo, or at least this implementation, has first-class objects. So let's say to add 2 to some number. I don't know. I hope that's, well, we'll also find out if it has scope for local variables. We want to output. How do we want to do this? We want to output add 1, add 1, no. I'll tell you a secret. I know this isn't going to work because I tried it earlier. Okay, so we defined the procedure or the function. So let's try and call it. Oh, wow, it totally worked. That's shocking to me. Okay, so now we've seen that we seem to be able to call this function from within another function, which makes sense. We didn't have to jump through any hoops. Can we pass this function as an argument? So let's do this. To apply function to some value, right? Actually, function might be a reserved word just in case. Let's call it funct. So to apply some function to a value, what would we do? Well, we would output funct to a value. Well, since add 2 worked, surely this will work, right? Let's see, apply, let's say we want to apply add 1, we'll do 100 to 100. What do we get? Not enough inputs to apply. So this might be a strictly syntactical thing. Essentially, it doesn't know what add 1 is. So let's try doing this. Add 1, 100. You don't say what to do with add 1. So we're kind of in a little bit of trouble here in that we're not able to pass that function, certainly as a partial function, which is kind of what we want to be able to do. So let's try and do something a little more aggressive. And what's actually happening here is that add 1 in this case is actually not a function. It's a string, and Logo doesn't know what to do with that string. So long story short, Logo doesn't have first-class functions, so you can't just pass them trivially. But we can do something a little clever. There we go. In that I believe we can do something like, and this is complicated, we could say run. And what run is going to do is run is going to take a list as an argument. And it will then apply, essentially it'll do what we want apply to do in this case. So let's see if that works. What was my apply, add 1, 100 was what I wanted. You don't say what to do with 101. That's actually correct. Apply, add 1, 100. So let's print the value. Good, it printed. All right, so this leads us to the question, can we implement fmap? Can we actually create, a kind of functor-like structure within Logo? So I actually did this earlier, and it took me about 20 minutes to work through the syntax. And so I'm not going to bore you by struggling through it. I'm just going to go ahead and implement it here. This quoting here, this thing would sometimes a local has to start like that, or you have to know that it's global. You have to prefix that quote. That's probably where about 15 of the 20 minutes went through, was getting that wrong. This was, I think, shipped in 1983, and this is a pretty good screen editor for 1983. You really need to appreciate how sophisticated this is. So what do we have? We have our function f. We have the thing or list that we want, or a container that we want map to be applied to. So if our list is empty, and really I'm only implementing this for lists because Logo doesn't have algebraic data types. What are we going to do if it's empty? Well, if it's empty, then we want to return the empty list. Otherwise, we want to, now this took me a while, okay? So you might think we can do just what we did before, which was essentially create a list of the function and the function's arguments, but it gets complicated because the argument that we want to pass to the function is itself a list, but we want it to be kind of appended to that list. So there's a little bit of syntax here. We've got sentence. So output is return. Sentence is essentially append. Run is saying that we're going to take the first item in this list and apply it. We're going to apply it to the first item in our list G. Got that so far? And that is closing that parentheses. Then we want to run again. This is the next thing, is we want to do the recursive step. So we've got to have, that has to be evaluated separately also. So we're going to have another run. This is all one line of code. If you break the line of code in the wrong place, everything falls apart and nothing will work. List, map, where we want to essentially create, but first is the essentially rest or cdr in list. All right, so what does this say? This says run our create a list which contains the function we want to map and the first element of our G argument. Run that, append that to the result of a list of the function, a list of ourselves, map, the parameter to map, which is f, and then the rest of the cdr of this argument G. Boy, that's hard even to say. So if you've implemented map in almost any modern language or any language that really kind of natively supports first-class functions, you could see that this is just kind of painful. I hope it actually works. So let's see, I have to remember how to actually define a variable here, because I've totally forgotten that. Say make x7, no. Make x7. You don't know how x, there we go. You don't know what to do with x. You don't know what to do with 7. So this is exactly what I was talking about before with forgetting what our various things are. All right, so let's create a list. We're going to make my list, and I want that to be, let's say, 100, 200, 300, 400, 500. Okay, does that work? Let's print it. Can I print a list? I can print a list. Lovely. We have our add one function already, so we have our map function already. So we're going to say map. I need to pass, again, the name of the function. I'm passing the name of the global function add one, not the function itself. And then I want to pass the instance of my list. I believe that's correct. And I think we want to print the whole thing so we don't get that error message. Moment of truth here. 101, 201, 301, 401, 501. So there you go. You can implement fmap in Apple Logo, but it's kind of a real pain. I don't think I would want to make a longer program in this language. Most interesting thing about this from my perspective is how incredibly featureful this is. I mean, for something that had to fit inside of 48K, so there's a lot in the manual which is available online about the memory management. So if we type nodes, well, print nodes, you could see we have 5541 nodes left, and that went down just by, will it keep going down? It'll keep going down. So that's how many blocks are left. We can define another variable. Let's define a long list. All right, nodes. Okay, and then you can garbage collect by using recycle. Long pause while it thinks about it. We're going to print nodes again. We got back a lot of memory. And so that's, I don't remember the size of these blocks. It's in the reference manual. I want to say they're, let's see, can I see what size a node is? Each node is 5 bytes long. So we got back around 5K just by running recycle there. And everything that we defined before should still be in memory. You could also erase objects. There's a lot of very complicated memory management utilities that you could use if you're writing programs of this. I know that at least one of my followers indicated that he kind of lived on Apple Logo in the 80s. And so I would just love some input from you on, you know, what kind of things were you making Was it all just drawing pictures, or were you able to use it for more kind of day-to-day practical stuff? Let us know. So that's it. That's Apple Logo in a nutshell. I'm not an expert by any stretch of the imagination, as I proved to you, but I had never really used it back in the day, so I was really curious to take a quick look, a quick dive into it. There's a lot of other obscure languages and implementations from the 1980s. The one that I'm kind of target fixating on next is Apple Pilot. Pilot is a very strange language. The literature claims it was intended to have the same sort of educational purposes as Logo. But when you look at the syntax, it's kind of a nightmare. And I don't want to front sell this too much, but it's a very strange thing. It seemed to be like the love project of one dude, and then no one did anything with it for many, many years in the 1970s. And then during the 8-bit explosion in the 1980s, I think the Apples, Ataris, and Commodores of the world were looking for ways to say, oh, this is educational. And so they kind of latched onto Pilot. There is a Pilot implementation for the Apple II. There is also one for the Atari 8-bits that I gather was used even more than the Apple version. So that might be my next shallow dive into obscure 1980s computing phenomenon. If you have another suggestion, if there's something that you've been curious about, let me know in the comments or on Twitter or Mastodon. All right, thanks a lot.